Okay, so when we're taking measurements, two things that we want to look for is precision and accuracy. So precision is how close the values are to each other. So a lot of times we'll do several trials of an experiment to check for precision. Okay, so for the example in our picture there, we have multiple arrows far away from the target, but all clustered there together, which shows good precision. Okay, so if you have measurements that are close to each other after you've done the experiment several times, then you have good precision, which is what you want. You want to be able to reproduce a measurement. Accuracy, we're looking at how close a measurement is to a true value or a known value. So for our darts here, the goal is to get the bullseye, right? So obviously this person has terrible accuracy because it's nowhere near the bullseye, but they have good precision. So I'm going to give you a couple of equations here to go along with this. Okay, so for precision, a couple ways to measure precision is using deviation. So deviation is when you take the average of your measurements and you subtract it by each value. So you would have a deviation for each measurement, okay? So value, I mean measurement. So you would do that for each measurement, average minus the value. And then we have deviation squared. So that would just be the deviation squared. So whatever you get for that answer, the first one, you would just square it, okay? And then we have standard deviation. Okay, so in this one's a little bit longer, but we take the sum of the deviation squared. So we would take the sum of the deviation squared there, because again, you would have a value for each measurement. And then you would divide n minus 1. So n is number of trials. Okay, and then you're going to take the square root of all of that. So standard deviation, we have the sum of the deviation squared divided by n minus 1, and n is number of trials, and we take the square root. So all of these equations are to show our precision, okay? Then for accuracy, we can use percent error. So percent error. Here we're going to use A. So A is the known value or the accepted value. Put that in parentheses here, accepted. Minus E, which is experimental. I'm running out of room there. Experimental. Okay, and then divide by A, so same thing, it's the accepted. And we're going to times all that by 100. So I totally ran out of room, I'm going to rewrite it down here. So A minus E, accepted minus experimental, divided by A, times 100. Okay, so the accepted is a known value, it is a value you would look up, so then the experimental is what you actually measured, okay? So the known value minus what you measured divided by the known value times 100. So it gives us an idea of how far away we are from that known value. Now, if you have a high percent error, that's a bad thing. That means you're really far away from the known value, but if you have a low percent error, that's kind of what we're shooting for. Okay, then we also have absolute error, which is pretty much the same thing as percent error without the percent and without the last division part. So Oh, and I forgot to mention this. You have to use absolute values because you don't want a negative percent error, okay? So here you're going to take absolute value A minus E, so the same thing except in minus the experimental. So I'm going to give you percent error real quick again because I forgot to put the absolute values. So it'd be A minus E divided by A times 100. Okay, so you don't have to worry about the absolute values, just if you get a negative, take the negative off. That's all you need to do. Okay, the last portion of this chapter is dimensional analysis. Dimensional analysis is used just to convert one quantity to another. Okay, so from one unit to another. And we do that using conversion factors. So an example of the conversion factor here is 1 inch is equal to 2.54 centimeters. But there are conversion factors that you are familiar with, which I have on the next slide here. 24 hours are in a day. So that's a conversion factor that we use. 60 seconds in a minute. You may know 12 inches are in a foot, or 3 feet are in a yard. Let's see here. 1 inch and, oh, that's the one from the last slide. 12 are in a dozen. That's a conversion factor. I know there's more than that, but I'm just drawing a blank right now. So there's already conversion factors that we're familiar with. I also gave you 1 milliliter is equal to 1 centimeter cubed. Okay, so remember that one. But here's one that you may not be familiar with is 453.92 grams are in a pound. Oh, I thought another one. 5,280 feet are in a mile. Okay, so all of these you may have used before. And then our prefixes can be used as conversion factors as well. So over here on the right, we have 1 kilometer is equal to 1 times 10 to the third meters. Or 1 centigram is equal to 1 times 10 to the negative 2 grams. 1 microsecond is equal to 1 times 10 to the negative 6 seconds. So our prefixes are used as conversion factors, okay? So here's what we're going to do. They're going to give us a unit, a number in a unit, and then they're going to say change it to this unit, this desired unit. Okay, so this is what our setup looks like. We start with what they give us, okay, which is our given right here. Then we use our conversion factor. This will be our conversion factor to get to our desired unit. Okay, so I have an example here. It says if a pig has a mass of 245 pounds, what is its weight in grams? So pounds is what's given, and our desired unit is grams. So what we have to do is we go to our conversion factor list. I have that posted in Canvas, and we find the conversion factor to go in between pounds and grams, and there is one. It's 453.6 grams is equal to 1 pound. Okay, so then we set up the problem. We start with our given unit. So here's our given unit that was given in the problem, 245 pounds. Next, we want to use our conversion factor, and we want pounds to be on opposite sides. So this pound right here is in the numerator. So for our conversion factor, we want this pound to be in the denominator. So they have to be on opposite sides for them to cancel out. Okay, if you have both pounds in the numerator, then you're just multiplying them. Okay, so then you would have pounds squared. So we want both the pounds to be on opposite sides. This one's in the numerator, this one's in the denominator. Okay, so those will cancel, and then we will be left with our desired unit, which is grams. Okay, so pounds cancel, and we're left with grams. So we take 245 times 453.6, and we get 1.11 times 10 to the 5th grams. Okay, so if it's in the numerator, multiply. If it's in the denominator, divide. Okay, so I'm just going to do a bunch of examples now for conversions. Okay, so first one, we have 16 gallons to liters. If you're not used to doing conversions, I suggest mapping it out, and I'm just going to do these problems, mapping them out so that you kind of get used to that. But if you're already experienced and know how to do it, then don't worry about it. Okay, so we look up, see if there's a conversion factor to go from gallons to liters. There is. 1 gallon is equal to 3.785 liters. Okay, so we start with our given, which is 16 gallons. Then we use our conversion factor. I want gallons in the denominator, so it'll cancel. 3.785 liters in the top. Gallons do cancel. And I get 60.56 liters. Okay, so we need to look at significant figures. We started with 2 significant figures. And remember, I told you that conversion factors have an infinite number of sig figs, or exact values have an infinite number of sig figs. So I don't have to worry about these significant figures. So what I start with is what I'm going to end with. Okay, so I want 2. So my answer is going to be 61 liters. Okay, then we're going 13 miles to feet. Okay, and we do have a conversion factor for that. 1 mile is equal to 5,280 feet. Okay, so we start with our given, which is 13 miles. We want miles to cancel, so I'm going to put 1 mile on the bottom, so it will cancel. 5,280 feet on the top. Okay, so miles cancel. And again, I want to... what I start with in sig figs, that's what I want to end with. So this is going to be, I just have this written out in scientific notation. So 6.9 times 10 to the 4th feet. I only want 2 sig figs, and I get that right here. Okay, next we're going from 1.01 times 10 to the negative 8 seconds, and we want to know what that is in nanoseconds. Okay, so we're going to use our prefix as a conversion factor. 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. So I'm just going to use that as a conversion factor. So I start with my given, 1.01, 10 to the negative 8 seconds. And I want seconds to cancel, so I'm going to put that in the denominator. 1 times 10 to the negative 9 seconds in the denominator. 1 nanosecond in the top. So seconds cancel. And I get 10.1 nanosecond for my answer. So I started with 3 sig figs, and I'm ending with 3 sig figs. Okay, next we have 100 kilograms. And we want to know what that is in pounds. Okay, so we look at our conversion factor sheet, and we find that 1 kilogram is equal to 2.2046 pounds. So I start with my given, 100 kilograms. Then I put in my conversion factor. I want kilograms to cancel, so I'm going to put that in the bottom. 2.2046 pounds in the top. So kilograms are going to cancel. I have 4 significant figures here, so I want to end with 4. So I'm going to get 220.5 pounds for my answer. Okay, then we have 8,944 millimeters, and I want that in meters. So I'm going to use my prefix as my conversion factor. 1 millimeter is equal to 10 to the negative 3 meters. So I start with my given, 8,944 millimeters. I want millimeters to cancel, so I'm going to put that on the bottom. Meters in the top. Oops. That cancels, and I get 8.944 meters for my answer. Okay, one more. 825 yards. We want to know what that is in kilometers, so you can look at your conversion factor sheet and see 1 kilometer is equal to 1,093.61 yards. So I start with my 825 yards, put in my conversion factor. I want yards to cancel, so I'm going to put 1093.61 on the bottom, 1 kilometer on the top. Yards are going to cancel, and that gives me 0.754 kilometers.